much for that introduction. It's wonderful to be here with you, Remi. We're really excited to be kicking off the machine stage here at the Web Summit. And I want to start off by just giving a little bit of context about Movidius and what makes Movidius a perfect fit for the machine stage, and where is the evolution of machines going in the context of these broad topics that we hear talked about. So we've chose the theme of EyeRobot, our machines catching up to science fiction. And so, Remi, I'd like to just start by asking you to give us a little bit of background about Movidius, what you do in the context of machines, computer vision, and artificial intelligence, and where do you see computer vision fitting into that broader context?
Thank you for the introduction, and thanks to the Web Summit team to invite us today. First, we're glad to be here as an Irish company, one of the few, and have the chance to address the audience. Like you said, Gaia, we're in the field of artificial intelligence, so we believe that there is a revolution in the making in the context of bringing autonomy in devices. A lot of AI right now is being talked about in the context of what you can do in the cloud, but the genesis of Movidius. Oh, sorry. Thank you. Is it better now? Bad sound with a French accent is a bad combination. The genesis of Movidius was essentially in the context of pushing intelligence from the cloud to the edge of the network. And by the edge, we really mean actually in devices, whether it's your car, whether it's a drone, whether it's your AR or VR headsets. And we took actually one of the key issues of artificial intelligence, which we believe is the most complex, which is around vision. Vision is actually a pretty complex task. It's actually biologically consuming 50% of your brain, really. It's very high resolution that you have to deal with, a very high frame rate, and a pretty complex translation from detection of an image to recognition of the image. And we thought that actually the company should try to go and enable visual extraction or semantic extraction to be done in those devices for many use cases that we can talk about subsequently.
So Movidius isn't one of the most exciting Irish companies, I would say, that's around today. They're on the verge of actually becoming a unicorn. They've been around for 10 years now, and a lot of the work that's gone into creating your phenomenal computer vision focused chips and work that is enabling the artificial intelligence network. All of that is really the underlying ecosystem that's required to enable the kinds of exciting machines that are able to be autonomous, that are able to provide the kind of science fiction capabilities that we're also excited about. So I'd love to hear what are some of the use cases, real-world applications that you find most fascinating?
Yeah, sure. What's very visible right now is the autonomous car. I think actually the ability actually for cars to essentially self-drive, and this is going to become more and more a predominant use case. Tesla released a software upgrade last week or 2 weeks ago. Drones is also going to be very prone to machine vision in the context of collision avoidance, sense and avoid. So the ability for the drone to fly, avoid objects, deliver objects as need be. Virtual reality is also very prone in the context of machine vision. It's about positional tracking for low latency and no motion sickness. It's about gaze, it's about gesture recognition. I think augmented reality is also a great example. And Gaia Dempsey is being one of the leaders in the field of hardware and software augmented reality for the workplace. maybe actually you're better placed than I am to give an example.
Sure.
Yeah.
So in the context of augmented reality, computer vision, that type of visual intelligence is absolutely critical to being able to deliver the experience. So you can think of computer vision broadly as being able to enable the device to not just photograph the world, but actually analyze and understand what the device is seeing. So that obviously becomes useful for the self-driving car so that it can understand the road, becomes useful for the autonomous drone or the autonomous robot so that it can navigate. But it also becomes very important in the context of devices for both augmented reality and other applications where you want to be able to give the cameras in the device that geometry of the world and that context so that you can meaningfully insert content. So for example, we focus on the future of work. We provide augmented work instructions at the site of a task being done. So for instance, say you're working on an oil rig or a wind turbine and you need to do a maintenance or repair task, we're capable of visualizing the step-by-step work instructions directly on top of the equipment or the machinery that you're working on, and that gives you the ability to minimize errors and also increase the job completion time because you are, instead of trying to figure out what you should be doing next, given step-by-step guidance. And so computer vision is the underlying technology that actually allows you to do that. There's lots of different other components in the stack that you need to get to work together in order to deliver the final experience. You need to have 3D content, you need to have rendering, but the computer vision is that core enabling technology that lets you meaningfully insert the content against the background of the real world.
Yeah, I think that we are when it comes to augmented reality, we are on the verge of a massive revolution. I think that actually AR will be the new UI of the future. I think that actually AR is going to revolutionize many industries, and I really believe that the approach Daqri took to verticalize the offering for helmets for the industries. I think it's going to be a very nice niche to prove the technology and grow it. And I got a lot of hope for where you guys are going. That's for sure.
Thank you. So I want to kind of segue into talking about where are we in computer vision from your perspective, and we talk about how AI or artificial intelligence. Can take the power of machines and allow us to accomplish so much in theory, but one of the key challenges is enabling artificial intelligence and machines to be able to do the things that we do so simply. So one of those things being vision. And where are we in terms of delivering on the science fiction future? Are we close? Are we far? What are the key challenges and why is it so difficult?
Yeah, that's a great question. I believe first off, all the use cases we've talked about for the past 5 minutes, they are not actually science fiction happening in 10 years from now. Actually, this is going to happen for some of them starting this quarter and for most of them next year. So clearly the deployment of artificial vision intelligence in devices is a clear reality. And obviously, if you have to go and project that versus human capabilities, there is still a long way to go. I think that right now we may be able to reproduce a vision system of a mouse. To the ability of reproducing the one of a human being, there is still a lot of work to do. Still, there are big inflection points ongoing right now. One of them is obviously the convergence between a very large cloud infrastructure, the very large compute capabilities now in the cloud, as well as the adoption and I would say the successful deployment of deep neural networks.
This has been actually a technology invented in the 70s by a guy called Yann LeCun, who is now the CTO of Facebook. And took actually a lot of time to get deployed because you needed both the infrastructure and the compute to make neural networks a reality, but you also needed actually the data sets to train those networks against a large amount of images. This is happening now, and I think that that's what's going on in the cloud. What's going on in the edge or in devices, obviously we've been at the forehead of deploying technology there, both processing technology as well as algorithmic technology. And we are now actually working with companies, Google being one of them, in deploying actually neural networks which has been extremely trained, extremely efficient into the context of devices that we carry every day. And a good example is, actually I've got one here, a good example is this project that we are doing, which is supposed to be a camera. Sorry if you can't see it very well. It's supposed to be a camera, and that camera is essentially going to be a wearable camera, and will be able actually to not capture any video, so not go against privacy, but rather actually capture metadata and being able actually to go and augment you. For example, I can see Gaia, and if Gaia is actually on my network, I'll be able to know what the latest tweet from Gaia were, or whatever I saw Gaia last time, or whatever it is. I'll be notified of this. But I will also be able actually to do, visual sensing on a daily basis to augment me, because we have right now too many cognitive information coming our way, and it will help us actually sort that out. This is actually only possible by the combination of new hardware, new algorithmic technology, and deep neural networks. And this stuff is not science fiction. It will launch next year, and will start to become actually, I think, a real trend in augmenting us through artificial intelligence. So I think those different trends is what makes the topic now extremely relevant. And makes deployment of visual or artificial vision intelligence a reality.
So you talk about the processing being pushed out toward the edge, and specifically this project, the Eyes of Things. Also, as in part of the broader context of the Internet of Things, there's lots of different components that make up the Internet of Things, right? We talk about having smart devices that can give us data that we can control and from our smartphones. Why is this context of pushing the processing out to the edge so important and so crucial? Because I know you talk about that a lot.
Yeah, no, that's a great question. I think there are many reasons for them. First off is latency. So think of it for your car. When you're going to go and give control of the car, you obviously do not want to wait for any sort of connection back to the cloud for you to know that you have to turn right. So the local intelligence is a key factor. Same thing for a drone. It's actually a different speed, but same type of problems. Second of all is, I think it's data efficiency. You are going to consume far less bandwidth by actually having the process to be done locally. And the third is power. And the power numbers are huge, because when you compound what it is to go and take decision in the cloud through the infrastructure, the cost of transferring packets and everything, it's a 1 million ratio between 1 million x more power or less power efficient to do in the cloud than to do it at the edge or in the device. So all of that combines are the trends which are pushing that intelligence to be pushed at the edge. And to tell you the truth, this was a gamble we took as a company. As a company, we years ago, 10 years ago, we thought that actually we built the company on two theses. The first one was, well, no, first of all, AI is going to come, which was actually a bit of a bet. And AI will come not only in the cloud, but will be pushed at the edge for this autonomy. And the second thesis of the company was, all right, so if you assume that it's being pushed at the edge, and you look at the amount of compute you need to process those things, you need to come with a brand new architecture. You need to come with a clean sheet and build that from the ground up. And that's those two elements were how the company was built. Believe me, 10 years ago it was not that clear as it is clear now.
So I want to give the audience a little bit of a sense of scale, because what you're talking about, this is really, I think, the crux of the matter, is being able to give the devices autonomy, whether that device is something as small as the camera that you're holding or something as big as a car, being able to give it the intelligence to make autonomous decisions instead of waiting for some kind of data process to go up to the network and back. So tell us a little bit about the scale and that's required to really make that work from a power perspective, from a processing perspective, and how you approach that.
Yeah. So I think that one of the best examples we found to explain that, I'm sorry for mic issue. One of the best examples we found to explain that was Rover. You guys know about Rover, the stuff that went on Mars. Mm-hmm. Rover was actually, the whole goal of Rover was to do what we called SLAM, which was simultaneous localization and mapping. And the first time it was sent to Mars, it was actually to go and reproduce the terrain of Mars, reproduce the 3D reconstruction of the surface of Mars, exactly, and create a route for subsequent visits. I found the example of Mars to work very well with a new movie coming out. So, this actually, the technology which was at the basis of doing, this 3D reconstruction and visual inertial odometry, which is a technical word used for this simultaneous localization and mapping, was actually literally fitting in this rectangle from a cubic standpoint. So that was what we ended up actually using. Now, if you look, and sorry, you will not be able to see that very well, but if you look at your fingernail, that may be easiest, this, the processor we use end up actually reproducing all that functionality, which is, sorry to be a little bit technical, but teraflops in terms of compute, which more or less, if you take your latest Mac, it will be 2 to 3x that compute power. In a little package from a chip standpoint, which is a 6.5 by 6.5 millimeters, so which is your fingernail. And all of that will consume in the hundreds of milliwatts. And this is where, to go back to what I was saying earlier, to calibrate on the numbers, we did that so in a super small footprint at super low power compared to that footprint at tens of watts, because we had the chance to start to fix this problem from the ground up. No constraints, no limits. We essentially created solutions specifically for that. And that's, I think, what makes now the ability to have artificial intelligence in this type of form factor is because, or in the device that Daqri is building as well, you have now the ability to have long battery life and provide a lot of visual intelligence to augment yourself as an individual, now that you get the technology underneath it, which is capable of doing it.
That's why I think that it's such an incredible story and it's such an incredible company, is that you had that vision 10 years ago to make that bet and to start with a completely blank slate in approaching it. And the use case of the Mars rover, that is taking taking humanity to new places that we've never been before. But the scale that you're operating at will be able to take that same computing power and put it in the devices that everyone has in their pockets, and that's incredibly exciting.
Yes. I think that the vision for us, and I think it should be also the vision for a lot of people in AI. If we can actually put a brain core. Today we're talking about vision, which is the toughest problem to fix in AI. But if eventually we can develop technology which mimics to some level of extent brain and deploy brain technology in many devices so that actually we are no more a slave of our smartphone, but we get servants around us to augment us, then we will have done something for the world, which I think matters.
So I think this is a really interesting kind of vein to go down, because throughout history, starting with, say, the domestication of wheat before, moving from foragers to agriculture, and then all the way through, to email and cars. We've continued to develop innovations that we think are going to make life easier and give us more leisure. And here we are on sort of this tipping point of having autonomous robots and AI and deep learning algorithms that are going to make our devices so smart that they can become these servants, as you say, that are anticipating our needs and understanding our environment. Remi, do you think that that is going to give us more time and more leisure, or is it going to continue to speed up the pace of life?
I'm an optimistic, so I have a belief that actually it will give us more time. But I also acknowledge that there will be a need for some level of ethical control on how far we can push the deployment of such technology. It could be misconstrued. It could actually have an impact on humanity, maybe not in the next 10 years, but in another years from now. And I think that actually, I think that overall it will help humanity progress. But I also am grounded enough to realize that as we're going to go and be able to mimic more and more of brain function and bring more and more autonomy in devices, there will be a need for a framework to make things actually, to put things under control. I think that actually anything related to super artificial intelligence is a topic that needs to be handled very carefully.
So what's the upside? Where do you see where does your optimistic side lead you to believe that where could we arrive if we were to maximize the value and the potential of these processing technologies and these enabling technologies that are going to create the next generation of devices that will be so intelligent that they can serve us and anticipate our every need?
No, I think that's a big question. I don't know. Eventually, I believe that curing diseases and potentially working on topics like immortality will become actually for real. I think that once you reach the threshold that Kurzweil called, I think, the law of infinite returns or something like this. When you reach that threshold where machines become so intelligent that actually they surpass us, I believe that, I hope that they can be put at good use for humanity, and obviously for sure disease is one issue, but I think we'll be able to work on topics like immortality. I'm a believer in that. I'm one of the believers in that thread.
That's incredibly exciting, and we'll essentially evolve into a new species at that point.
Maybe.
Well, thank you so much, Remi. This has been so much fun. It's been great to have this conversation.
Thank you.
Thank you for having us.